Hello and welcome to this project on natural language processing for text classification with NLTK and scikit-learn presented by EduOnix. In a previous project we dove into the foundations of natural language processing. We covered things like stemming and tokenizing. Today we're actually going to use those to do feature engineering and start applying sklearn classifiers for natural language processing. So this is a text classification task. We are going to be looking at a data set of text messages and classifying them as spam or not spam. So this is something that is very valuable to companies. This is something that Google does extensively, spam filters for their Gmail accounts. So we're going to be looking at the basics of that. We're not going to do as good of a job as Google certainly, but we are going to cover the basics and get some working models. So let's go ahead and dive right in. We are going to be working in Jupyter Notebooks as always. So open up a command prompt and then cd to whatever directory you want to open your Jupyter Notebook in. Remember, wherever you type Jupyter Notebook or Jupyter Lab is where your Jupyter Notebook is going to open in that current directory. So I'm going to use Jupyter Lab. This is something I've switched to over the last couple projects. Jupyter Lab helps us see the current directory that we're in at the same time, as well as gives us some other beneficial functions that we can use. So that's why I've switched over to Jupyter Lab. We're going to be downloading a couple files. We're going to have a couple different files in our directory, so it's nice that we can see them, but certainly not necessary. So if you want to use Jupyter Notebooks, go right ahead. Alright, so currently my tutorial folder is empty. That is why you see nothing in that directory over there to the side. In fact, if I pull this over, you'll be able to see the same thing. Oh, here we come. There we go. So right now, tutorial folder is empty. That's okay. We will start filling it up soon. Alright, so pull that back off to the side. I'm just going to open up a default notebook. And again, this populates over here. So let's give this a name. Let's go rename. We'll say text classification, since that is what we are going to be doing today. Alright, so first things first, just like we do in all of our projects, we are going to be importing the necessary libraries. And then to ensure the necessary libraries are installed correctly and up to date, we're going to print the version numbers for each of these libraries. This is something we've been doing to ensure reproducibility as well. And it also helps everybody ensure that they've got all of these libraries downloaded and installed correctly, because if they are not, they will not import correctly in this step. So this is what we're going to be using today. We've got NLTK to handle our natural language processing, sklearn to import some machine learning classifiers for us, NumPy is going to be helping us with some computational tasks, and then Pandas, we are going to be using a Pandas data frame to store our data. So let's go ahead and print these off. I'm using Python 2.7, which we will see here in a second. And then let's get these in here. So NLTK will have a version for that. .format NLTK.version. There's that. Let's print off the scikit-learn. .format sklearn version. Alright, there's that. Pandas format. And then on to our last one here, NumPy. Alright, so Shift Enter will run this and make sure that these are all importing correctly, and indeed they are. So these are the libraries we are using. These are the versions that I'm using. These versions and anything probably more recent than this should be good to go. But if you're using different versions and you run into errors later, this could be something to investigate. Alright, so first things first, let's load the data set. I'm going to make a nice little markdown cell here so we can have a nice looking notebook. So load the data set, that's our first step. I'm also going to import some of these under different namespaces. So I'm going to import pandas as PD, since we're going to be typing that a few times, and then import NumPy as NP. Alright, but first things first, we actually have to go and get our data set. So we're going to have to download this, and this is going to come from the UCI Machine Learning Repository. It's the SMS spam collection data set. So here we have over 5,500 text messages that were collected for research purposes. So it's a multivariate text domain theory data set, and it can be used for different classifications and clustering tasks. We are going to be looking at the classification today. So here you have some examples. These are just text messages, and they're actually classified as ham or spam. So this is a spam message, or anything else is going into the ham. So we have a wide variety of these. You know, some of these obviously spam, some of these obviously not spam. So that is what we're going to be trying to determine today. So let's go here into the data folder, and if you just install this zip right here, it's just the SMS spam collection.zip. We can go ahead and pull that up. So this is going to just come down into the downloads. I've got this right here. What I'm going to do is I'm going to extract all. I'm not going to extract it to my download directory though. I'm going to put it over in the tutorial, which is where I started my Jupyter Notebook. So awesome. Now if I bring this back over, you can see in my tutorial folder I have my Jupyter Notebook, which I started, my Jupyter Notebook checkpoints, which just controls the saving where everything's at. This is a README that comes with the SMS spam collection. That's actually what we were looking at back in the main page right here. This is the README that's populating this page. So we've seen that information already. Alright, so there we go. We have this in here. This is actually a text file. This is what we are going to be importing into our data set today. Alright, so back over here, and I'm actually going to bring this down, put it onto the tab here. Alright, let's go ahead and load that in. See, now actually over here in Jupyter Labs we see this off to the side. We've got the README over there as well, although we don't need that. So load the data set of SMS messages, and again this is going to be using pandas, so we're going to have a data frame. So we just have PD, read, table, the name of the file, so this is SMS spam collection. Got an extra capital here, there we go. And we're not going to pass names to this yet, so we'll say header equals none. We also need to pass an encoding since this is a text file, so we'll just say UTF-8. Alright, so we go ahead and run this, and it looks like it successfully imported this because we've got the number there. It's no longer thinking. But let's go ahead and investigate that a little bit just to see if it did in fact import correctly. Also, we need to familiarize ourselves with this data so that we have an understanding of what we are working with, and that's going to really help us when it comes to engineering different features to use for our machine learning algorithms. So let's go ahead and print off dataframe.info. This will tell us some good things, and then let's also print off the data frame's head. So if we run this, we get all this information back. So we have data, and then we have columns. We have 2 total columns. So we have a classification right here, ham or not spam, and then all the way over here we have just whatever length of the text message. So 5,500 text messages, 5,572 to be exact, with the first column here being a classification of ham or not spam, or ham or spam. So spam, text message, or anything else. Let's go ahead and check the class distribution just so we know how many spam messages we have. So classes I'm going to just set as the data frame first column. Then we can print classes and value counts. This will tell us the unique values and how many of them we have. So we have ham 4,825, spam 747. So, which makes sense. We have way more actual text messages than spam text messages. So we don't have equal class distributions here. This skewed class distribution sometimes can affect the performance of machine learning algorithms. So oftentimes we'd want to normalize this so we had a 1-to-1 ratio of spam to ham. But in this case, we're just going to leave it be. We don't want to overpredict the occurrence of spam anyways, so we can just leave it as such. Alright, so we've got our data set in here. We've got all our text messages. Now we actually have to get into pre-processing the data. So let's go ahead and give another markdown cell here. We'll call this 2. Pre-process the data. Alright. So one thing that we have to do is we're going to need to convert the class labels to binary values. So instead of having a classification as ham or spam, that doesn't really make sense to a machine learning algorithm. We're going to say 0 is going to be equal to ham, and then 1 is going to be equal to spam. And to do this, we can use the sklearn label encoder. So let's go ahead and import that from the sklearn library right now. So from sklearn.preprocessing, we are going to import the label encoder. And what this label encoder is going to do for us is exactly this. It's going to convert these class labels to binary values for us. So if we initialize an instance of the encoder, so we have encoder equals label encoder, initialize that instance there, we can say y is equal to the encoder dot fit transform and then classes. And remember, classes is just the first column of our data frame, the ham or spam classification. Alright, and just to see if this worked, let's go ahead and print out the first 10 instances of these. We need some parentheses here. So this is just colon, so all of the instances up to the 10th one. So print off the first 10. And if we run this, it looks like, yes, indeed, we did get a successful conversion. We have all zeros and ones here. And something that might actually be worth doing is if we print the classes, first 10 of these, we can see indeed we have ham, ham, spam, ham, ham, spam. And just the same way down here, our third one is spam, 4th, 5th, 6th, spam. So we have the right conversions here. Everything got switched over appropriately using this sklearn preprocessing label encoder. So sweet, good start. We have binary values as our class labels. This is a good place to be. Alright, next thing we need to do is we need to store the SMS message data. So the text messages are going to be the data frame, but the second column. So those entire raw data messages. And let's just make sure we got these. Let's print these text messages. We'll print off the first 10, see what they look like. So there's that. If we run Shift Enter, and here we go. So these just look like generic text messages. Looks like we've got some spam messages in here as well as some non-spam. Some wonderful spelling in some of these. I'm with you guys probably. I certainly don't always spell check my text messages. So that is something we also have to work with, is this isn't just perfectly clear cut, nicely correct spelling text. This is people mashing on little keys as fast as they can to send quick little blurbs to other people. So it presents us with some other different challenges than we would typically have in natural language processing because it's not nicely formatted. All the spelling isn't perfect. Alright, so now we actually have to move on to regular expressions. So we want to switch some of the things in these messages. For example, if we have an email address in a text message, we don't necessarily care what the specific email address is. We just want to know that, hey, there's an email address here. So using regular expressions, we are going to replace email addresses with just email. We are also going to replace URLs with just web address. Money symbols we can replace. 10-digit phone numbers, other numbers. So these are different expressions that we are going to replace with a generic placeholder, because this is going to be it's going to make the machine learning algorithm understand better. For example, so if we don't do this step and we do get an email address in the text message, that is going to likely be the only text message in our entire data set with that specific email address. So that doesn't actually help us learn too much information from a machine learning standpoint when no other text messages have that specific email address. However, if we have a text message that says it has an email, it has a web address, and it has a phone number, that is much more informative to the algorithm than, hey, there's these 10 specific digits and this specific email. So regular expressions can be kind of difficult, but that's okay. We are going to dive into this really quick. So here I have some of the basics of regular expressions, so I'm going to paste this in down here. These are just some common regular expressions that I have pulled from Wikipedia. So we are going to be using things like this to define email addresses, define phone numbers, etc., etc. So there's actually some helpful resources out there, so we don't have to combine these characters to come up with our own expressions for an email address. We can actually use the regular expression library to do stuff like this for us. So this is the regexlib.com, the regular expression library. So if we simply search for something like an email, we are actually going to get some results of already generated regular expressions that will denote different emails for us. So for example, this first one, it didn't get very good rating, but this is a simple email expression, and it has all these other descriptions. For example, doesn't allow numbers in the domain name, so probably not something we want. And then it gives some examples of expressions that it would match, and some examples of some expressions that it would not match. So all of these are a little bit different. These have just been submitted by different authors. Some of them got better ratings than others. Some of them cover more types of emails than others as well. So I've already pulled some of these in. I'm not going to spend too much time typing these out, but we can just start replacing some of these in our raw text message data right here in Jupyter Notebooks. So we're going to use regular expressions to replace email addresses, URLs, phone numbers, other numbers, some symbols as well. We're going to do some math symbols, or some money symbols, sorry. Alright, so first one's first, let's replace email addresses with simply email address. Alright, we'll use that. So we have our text messages up above. It's just stored as raw text message data. Each of these, it's a list of strings at this point. So what we can do is we can say processed. This will be our processed text message data. We have text messages dot string. So this is string dot replace. And here's where our regular expression actually comes in. So unfortunately, you might have to type these out if you already, or if you don't currently have access to the source code files. But this is the regular expression I'm going to be using for an email. Again, these were pulled from the regular expression library. So it's really nice that we don't have to think through and sit there and kind of ensure that we're getting what we need to here. Alright, and so this is the string we're going to be replacing. So any expression that matches this, and let's replace it with email address. Let's just ADDR there. Alright, so we'll place it there. There's that. So here's our regular expression, replacing anything in our text messages that matches this regular expression with this email down here. And you see some of these expressions here. So, for example, we have the brackets, matches the preceding element at least m and not more than n times. So we have a minimum of 2. We have no maximum on the end here for A through Z, matching A through Z. After our @ sign, we have our caret here, matches a single character not contained within the brackets. So this is going to match just this bracket here. Any character other than a slash or a dot, or rather than a dot here. So if you want to go through and kind of look at what these are doing a little bit more, you can certainly take the time to do so. A big part of natural language processing is these regular expressions. However, today we are going to be focusing more on the machine learning, so we are going to kind of skim through this probably faster than we should. So let's replace web addresses. So web address, so processed equals processed. Now we're going to pull in this already processed strings, text message strings here. So dot replace. Over here I'm going to copy in my regular expression, which I got for web addresses. There's that. So for example, HTTP, a normal web address here, comma, we'll replace that with simply web address. So there's that one. Let's go ahead and replace money symbols. There we go. With money sim. So this data was actually, some of it was pulled from Europe. So we have both pound signs and dollar signs. So I'm going to copy in my regular expression here. This one's not hard. It's just the signs. If you want it, if you actually have to type this out, you don't have a dollar sign on your keyboard, you can use the Alt key plus 156, and that will type a pound for you right there. So Alt and then type 156. You might need to make sure that your numlock is on. It'll give you a pound sign. Alright, so there's our expression. Any of these money symbols, replace these with money symbol. Sweet. Good to go. Place 10-digit phone numbers with simply phone number. So process equals processed dot str dot replace. Pull in our regular expression here. This one's a little bit more complicated, so that it will handle phone numbers with dashes, without dashes, parentheses, no parentheses. However, this does require a 10-digit phone number, or I believe it's a 9-digit phone number as well, which is okay. We would expect a phone number from a spam text message to include the area code, because they're trying to send this to a large number of people. We're also just going to replace normal numbers with number. So processed equals process dot str dot replace. Pull in my regular expression here. Paste that there. And replace that with number. So again, if you want to find more regular expressions, you can find them from the regular expression library. Regular expressions are used for things like ensuring that you have a strong enough password, or ensuring that you have a valid email address that you're entering into different text fields online. They have a lot of different applications. Alright, I'm going to run this cell, make sure everything works appropriately, and yes, it does. We've processed our text, although we're actually not quite done. We're going to do a couple more things. We want to remove punctuation. It's not going to be that important for our classification here. So str.replace, and our regular expression here, this is going to denote any punctuation. We're just going to replace it with a space. We don't need punctuation here. Actually, let's replace white space between terms with a single space. So if we have double spaces, we want to replace that. We'll have our expression here. So there's our regular expression. And again, let's replace this with a single space. And then finally, last one, we're right there. We're going to remove leading and trailing white space. So if we have spaces before or after this text message, we're going to replace them as well. So .str.replace, grab my regular expression, and then replace it with simply nothing. So there we go. Alright, so there's that. Let's make sure this runs. That was a lot of regular expressions, and I apologize deeply if you had to type all of these long guys out by hand. You're going to become experts at typing punctuation and using the shift key, probably. Alright, but we've got those now. This was a very important step. You can't just skip by this if you're doing text classification in an application that requires natural language processing. So regular expressions are going to be an essential part of the pre-processing that we're going to do for our data. Alright, we've got the regular expressions. Now we can move on to some other things, such as changing the words to lowercase. We want to do this because, for example, like the words hello, hello, and hello are all the same word. And we want to ensure that we capture that. They all mean the same thing. So process.str.lower. Pretty simple. Let's print this out, see what we're working with now. So we'll just print out some of these. So here's all our text messages. And we shouldn't see any phone numbers. Again, we're skipping by the majority. This is only showing us the last bits of these. So we got standard text messages. Some of these are spam, some of them are not. Looks like we got some spam up here. So good. These all look like nice lowercase normal text messages. I don't see any double spaces. I don't see any punctuation. So we are good to go. It looks like all of our regular expressions functioned appropriately. So we shouldn't have email addresses, phone numbers, URLs, punctuation. We're all lowercase. It's looking good. So let's go ahead and move on. So in the previous project, one of the things that we did was remove stop words. And we talked about stop words a little bit. Stop words are those words in the English language that actually don't add any useful information to the like message that you are trying to say. It's not going to change the meaning at all. So we're going to remove those from the text messages. And to do this, this is exactly what we did in the other project. We are going to import the stop words corpus from NLTK. So this is just a list of stop words in the English language. So we can import this as a set. Stop words equals set. Stop words dot words pull in the English ones here. And there we go. But we actually have to process these now. So processed equals processed. And we're going to apply a lambda function here. So we're going to do this all in line. We're going to remove these. So we're going to loop through this set. So lambda and x for our generic variable. So we'll have a blank string here, and we're going to join to it any term for term in x.split. And x here is going to be all of our text messages if term not in stop words. So here we have this empty string, and for each text message, we are going to append to this string all of the words as long as they are not in the stop words set that we imported from the NLT corpus. So let's go ahead and apply that, and looks good. We went ahead and did that pretty quickly, so that actually worked really well. And then the next thing we actually have to do, now that we don't have stop words, we are going to stem the words. We're going to extract the word stems. So stemming is another thing that we talked about in the previous project. For example, we don't need an ing on the end of words. We don't need these tenses necessarily. They're not going to tell us a lot of useful informations. So we're going to remove the word stems using a Porter stemmer. So Porter stemmer equals nltk.porter stemmer. We'll initialize this here. And then again, we're going to do a lambda function. So processed is going to equal processed dot apply lambda x again. And we're going to do the same thing we did before. Oof, there we go. Join to this the stems now this time. So we're going to do stem term for term in x.split. All right. So we should be able to go ahead and run this here. This one takes a little bit longer. The Porter stemmer, not quite as quick as simply a set of stop words. But hey, looks like we're good to go. It was actually quicker than I expected. Let's just one more time print off these processed text messages. See if we can notice any changes from our messages up above. So for example, in these first two messages, these have been shortened down to just the strings. For example, we don't have joking anymore, we just have joke. So they're just the stems of all of these text messages. We don't have any stop words in here. One of these, date Sunday, really straightforward here from this guy. Now, let's see what that was before. So I have a date on Sunday. All of these I have were stop words removed. Now we just have date Sunday. So we can see that our stop words, removing them actually worked, and the stems actually worked as well. So we see only the stems in these text messages now. Alright, so these have been shortened down dramatically, and we are good to go. We can move on to generating features. So feature engineering is the process of using domain knowledge of the data, which we have gained by going through these, to create features for machine learning algorithms. So that's exactly what we want to do. So in this project, the words in each text message are going to be our features, and for this purpose it will be necessary to tokenize each word. So that's actually what we're going to do first. So from nltk.tokenize, we are going to import the word tokenize. So this is creating a bag of words model. And this is something we talked about in the previous project as well. Simply extracting all of the words as tokens is called a bag of words model, because you have this list of just all of the words, and that's actually what you're going to use for the features. So we can say for message in processed, words is going to be equal to word tokenize, and we'll tokenize each message. And then for W in words, we'll append these, so all words dot append W. And then what we can do is we can actually do we can build an NLTK frequency distribution off of this. So we'll have all words equals NLTK dot frequency distribution all words. All right, and run this. This should go pretty quickly. And yes, indeed, we have our word tokens now. Let's just ensure that what we're going to do is we're going to come down here and we are going to print the total number of words and also the 15 most common words. So we can do that, print number of words, and we'll substitute into that dot format length all words. So there's that. We can also print off most, oh, need an apostrophe here, most common words dot format. And this is pretty straightforward. Since we built this frequency distribution up here, we can just do all words dot most common. Let's go ahead and just pull the first 15. All right, so we print these off. So we now have 6,562 words, and these are word stems. So we have 6,562 stems, and this is also not including the stop words. So you might be thinking about this, wow, we had 5,500 text messages. What are these one-word text messages? No, it just so happens that a lot of these, when we concentrate them down into the stems, there are fewer word stems than you would think. Some of the common words, number one actually is number, you. Everybody's using just a you to text you these days. Coming in next, we have call, go, get. Some of these are stems that have been concentrated down. Okay, free, day, no. Love, good to see love coming in here in the most common words. So here we have our 15 most common. We're going to use a lot more than this for our features. We are actually going to use the 1,500 most common words as features. So what we're going to do for that is simply use the 1,500 most common words as features, and you could use more or less. This is just a good number that encompasses a lot of the most common words, but isn't so many that it's going to take a long time for our machine learning algorithms to train. The more features you have, the longer it's going to take. We can simply say word features is going to be equal to a list, all words dot keys, and we're going to append to this the first 1,500. And since this is sorted by the most common, we can just type this as like this. All right, there we go. We have our word features. We're good to go there. Let's actually now, we're going to define a function that will determine which of these 1,500 word features are contained in each review. So we can define a find features function. And to do that, we simply type definition here, find features for each message. So we're going to pass it a message. So words equals word tokenize. We're going to tokenize this. Tokenize the message. Features, we're going to have an empty dictionary to start. And then for word, in word features, which is that list we just generated here, features word equals parentheses word in words. All right. And then we can return features. So this is only going to happen if the word is one of the words in this text message. All right, and let's see some results. To do that, we can simply have features equals find features. We'll call our function now. Find features. Let's just do this for the first text message here. So index 0. You can do whatever text message you want. So for key value in features.items, we'll say if value equals true, so that feature is contained, we'll print the key. So let's go ahead and do this. Looks good. So these are some of the words in this text message that actually are in the most common, 1500 most common. If we actually just print this text message, you see some of these. So available, this is the stem for available. Buffet actually gets in there as well. World, great. But this is potentially a name, doesn't make it into the most common, which makes sense because the specific name probably doesn't come up all that often. All right. And we can actually print out all of these. If we want to just look at all of the features, we can just print off features that we just generated right here. So if we print this off, this is going to be a list of all of the words, the 1500 most common, and whether or not they are contained in the text message. So that makes sense why these are all Boolean, a true or false, and we should only have a couple true, not seeing them in there. Then again, this is a big list. So we actually printed off all of the ones that were true right up above here. There's just these 4. And this isn't alphabetical, so they're going to be kind of hard to find. I'm just going to clear this output. But this is giving you an idea what the features are going to look like for each text message. So each text message is going to have a feature set like this, where it is a true or false for every single word in the 15 most common words that we have. So let's go ahead, clear outputs here. We'll get rid of that and move on. So we have this find features function now, and we did it for an example. Now let's do it for all of the messages. So what we're going to do, find features for all messages. First things first, we're going to zip together our process text message and Y, which is, if you remember, the spam or not spam binary value label, class labels here. Next things first, let's define a seed for reproducibility. So we'll say seed equals 1. Then we can do np.random.seed equals seed. So setting our random seed through NumPy. We're also going to do np.random.shuffle. Let's shuffle these text messages as well, just in case, for example, all of the spam comes towards the start of the data set or something like that. Shuffling is always a good idea. And then we can call find features function for each of these SMS messages. So this is going to be your feature sets. It's going to be equal to, we'll do some brackets here, parentheses, find features of text label. So label is going to be the class label here for text label in messages. So messages has both of these texts and these labels because we zipped them together right here. Alright, so let's go ahead and run this. This one's actually going to take a little bit of time because, again, it has to loop through and generate that big long list for every single text message that we have. And we have 5,500 of them, 1,500 words in our feature sets, so it takes a little bit, but still pretty quick in Python. Alright, last things last. Let's go ahead and split these feature sets into training and testing data sets using sklearn. So we'll split training and testing data sets using sklearn. So we've used this model selection package before. From sklearn, we're going to import model selection. And then we can simply do training testing equals model selection dot train test split feature sets test size equals a nice even 25%, since we have a lot of text messages here, and then random state, so we get the same split here, we can set to seed. Alright, and in the past, sometimes when working with this model selection package, we've had, for example, like an X-train, Y-train, X-test, Y-test. We only need the training and testing here because of the way NLTK actually gets past these parameters. Okay, so the last thing we need to do here is run this. So we'll split these up, and that goes really quick. And let's go ahead and print out the length of our training data. Let's also print the length of our testing data. Let's add some nice comments in here. Say training dot format and we'll have a testing. Oh, here we go. Testing dot format length testing. Alright, we run this. So training, it actually got testing. Oh, I spelled wrong. Here we go. So training and testing, we've got 4,179 training text messages, and then we're holding back 1,393 for our validation or testing data set. Alright, we're good to go. This concludes all of the pre-processing we have to do before deploying our scikit-learn classifiers with NLTK. We have a bag of words models here, and we've engineered these features to be whether or not the word is contained in a list or a set of most common words for each of these text messages. We did some stemming, we did some tokenizing, we removed stop words. We used some regular expressions, all some of the fundamentals that we covered in our previous project, so we're building on that now. Alright, so we're good to go. Keep listening, and in the next video, we will start deploying machine learning algorithms. Thank you very much.